Okay, I'm back, and now we're ready for part 5 of the lab that says determining the distance to the star. So what you should have accomplished by now is you should have measured the relative magnitude of the star, which is similar to the apparent brightness of the star, and you should have also have measured the absolute magnitude of the star, which is similar to the luminosity of the star. And so just like you could use the photometry equation whenever you're dealing with the apparent brightness and the luminosity in order to figure out the distance to a star, we're going to have another formula that's based on the photometry equation in order to determine the distance to the star. So if you go down to part 5 of the lab, it says determine the distance to the star using either the equation or graph shown in the concept introduction. So let's go up to, in the lab, to, again, the concept introduction, and you got equation 16.3, and you also have a graph. So there's actually two different ways of figuring out the distance to the star. Now, normally I would recommend do the graph first, but it may turn out that your answer doesn't fit on the graph. And if it doesn't fit on the graph, then you're going to have to use equation 16.3. So I made up some numbers. So I made up that the absolute magnitude of a star is 7, and that the relative magnitude of this star is 5. And what I want to do is first use the graph to figure out how far away that star is. So if you use the graph, it says absolute minus relative on the vertical axis. Absolute minus relative. So 7 minus 5 is 2. So you would find 2 on the vertical part of that graph, then bounce it off the red curve down to the bottom, and then read off what the distance is in parsecs. Now, I think it's about 3.5. You might want to try it yourself. So find 2 on the vertical axis, bounce it off the red curve, go down to the bottom, and see what that distance turns out to be. So I'm just going to say it's about 3.5. So I will put that down up here as my estimated distance using graph equals 3.5 parsecs. Alright, now let's do the same thing, only with using equation 16.3. Now notice it says relative minus absolute. On the graph, it was absolute minus relative, so be very careful. Relative minus absolute. So that's going to be 5 minus 7 equals 5 logarithm of the distance minus 5. Alright, 5 minus 7 is negative 2. Okay, what do I need to do next? I need to get, eventually I wanted to say distance equals something. So what do I need to get rid of? I need to take the negative 5 over to the other side of the equation, so the negative 5 becomes a positive 5. So that I'm going to have then 5 minus 2 equals 5 logarithm of the distance, and then 5 minus 2 is going to be 3, Alright, what do I got to get rid of next? Got to get rid of that 5. So I'm going to divide both sides by 5. And so that's going to be 0.6 is equal to the logarithm of the distance. Now we got to do something that we haven't done before here in class. You should have learned this in your algebra class, but the opposite of a log is called an anti-log. So we need to find the anti-log of 0.6. So the distance is equal to the anti-log of 0.6. So the way that you do that is, I just happen to have my Texas Instruments calculator here, and the logarithm button is the actual button right there. So, but what I want is the anti-log, which is right above it in yellow. So what I'm going to do is press 0.6 and then my second function key and then my logarithm key, and I get 3.98. 3.98. So I entered this number, and then I pressed the shift key and then the logarithmic key, and then that gave me the anti-log. And so this gives me that my distance is equal to 3.98 parsecs. But what did I think it was? 3.5. So it's not bad. So you're going to use the calculated one is always going to be the more accurate one. The one using the graph it's easy to do, but it's not going to be as accurate as if you use the formula to get it. Okay, now let's go back to the lab though. Go back down to part 5, because it says convert it to light years. So once you've got this number, 3.5 parsecs, you need to convert it to light years. Okay? Now, the relationship is that 1 parsec is 3.26 light years. So there's my conversion factor. So if I've got 3.98 parsecs, then in order to go to light years, I just need to multiply that number, 3.98 times 3.26, and then that would be the number in light years. Okay, and then you're going to enter these numbers in the appropriate yellow boxes. So you've got the calculated distance to the star using the graph or the equation, and then you've got the calculated distance to the star in light years. Okay, so let me stop the video here, and then when I come back we're going to talk about then how to use the HR diagram to get us even more information.